Hello everyone, myself Jayaditya. I am currently pursuing BTech second year in VVITU in Electronic Circuit Communication Engineering. I am here to explain detailed explanation about Hilbert transform and definition, explanation, applications and comparison and its usage. First, what are the Hilbert transforms? The Hilbert transform is a transformation of a signal. It is mainly used to convert a signal into analytic signal, which means complex form of a signal. Hilbert transform means transforming of a signal by 90 degrees. Now let us go deeper into the Hilbert transforms. What is Hilbert transforms? Mathematical operation. A linear operation that transforms a real value function into another function, which means u of t is converted into h of u of t. Next, Cauchy principal value. Define the convolution with means Hilbert transform is also be represented as h of u of t, which means 1 by pi into integral minus infinity to infinity u of t t minus dt by t minus tau, in which tau by t minus tau is also another time. Here, as explained before, in Hilbert transform 90 degrees phase shift takes place. If your signal was sinusoidal, then we will apply the Hilbert transform, the phase shift by 90 degrees and it becomes cosine. These unique properties make the Hilbert transforms indispensable for signal analysis particularly and creatively in the sequence. Intuition behind the Hilbert transforms. It means why Hilbert transforms is used. Real to quadratic. It transforms a real signal into its quadrature or imaginary counterpart. As I said that some analytic signals for analysis of signals, we use some complex signals. To get the imaginary part of the signal, we use the Hilbert transforms. Next, analytic signal construction forms analytic signals, which means z of t is equal to u of t plus I into h of t into u of t, where I is the imaginary part. Next, frequency domain effect. It acts as a filter shifting all positive frequencies components by minus pi by 2 and negative frequencies by pi by 2. When we apply Hilbert transforms, it shifts by 90 degrees. Next, Hilbert transform versus Fourier transforms. What are the difference between these two? As we know that Fourier transforms is also a converts from time domain to frequency domain. For Hilbert transform always operates in only time domain. Here he is the global amplitude and phase spectrum. But here a 90 degrees phase diagram Hilbert transform take place. Decomposing signal into constitutional sinusoidal in Fourier series. Use it to form an analytic signal for modulus analysis in Hilbert transforms. See, analytic signal are mostly used for modulation, which means transformation of a signal. Most of the same modulation process Hilbert transform are used, while both are integral transforms. We, we apply integration both transforms, which means for Fourier transforms and Hilbert transforms. These have distinct purposes. Digital analysis show how Fourier transforms convert a time domain signal into frequency domain signal. Well, Hilbert transforms change the shifts the phase 90 degrees of the original signal to get the analytic signal, which means modulation of your analysis. Let us go deeper into it. Applications of the Hilbert transform. What are the main applications of Hilbert transform? Let's see. Signal processing. It is used in envelope detection, instantaneous frequency estimations, and creation of the signal. Creating analytic signal for complex and demodulation. Already said. Next, communication. Essential for analyzing amplitude modulation and frequency modulation signals. Biomedical engineering. It is also mainly application biomedical engineering, applying neuropsychological signal analysis from task line, latency analysis, and phase synchronizes EGC or EGC data. ECG is nothing but a scanning. Here also to get medical reports, we use the Hilbert transforms or biomedical engineering. Next, vibrational analysis. Crucial for non-linear diagnostics, fault detection in machineries, and model analytics in machine engineering. If any detect, we can find by Hilbert transforms. Next, Hilbert transform ability to reveal instantaneous signal characteristics make it invalid according to diverse scientists and engineering dispels. Visualization the Hilbert transform effect. As I said that it is a input signal. When we apply the Hilbert transform, the phase is shifted by pi by 2, which means plus pi by 2 or minus pi by 2. Now imagine an original real value signal such as cosine wave. We choose a cos wave. When we apply the Hilbert transform to sine wave, left left original real valued function. It is cos wave. We can apply sine wave. These two components together form an analytic signal, enabling clear representation of instantaneous amplitude. Then amplitude also does not change, just surface changes. Simple. Let us take an example of Hilbert transform. Let us consider a fundamental signal to illustrate the Hilbert transform effect. First, original signal. Given a real value cosine function, which means u of t is equal to cos omega t. Next, when we apply the Hilbert transform to u of t, the process of Hilbert transform, how it occurs and applies the u of t. Now, Hilbert transform result. H of u of t is equal to sin omega t. Why it is sin omega t? When we apply the Hilbert transform, means signal is rotated into 90 degrees. Analytic signal. Combining this yield the analytic signal of a complex exponential signal, which means z of t is equal to cos omega t plus I sin omega t c. See here. Here the imaginary part also we can take in. So cos omega t plus j omega t can be also written as e power j omega t, which means a complex signal a required or have obtained. Now step by step computation of example. From the before example, now I will explain the process of Hilbert transforms. First begin with the signal. U of t is cos omega t. When we apply Fourier transform, integral minus infinity to infinity x of t dt, which means e power x of t j omega t dt. The Fourier transform consists of impulses located at the frequency domain. Fourier transform, as we know, that converts the time domain into frequency domain. Now, when we apply u of t equal to cos omega t Fourier transform, we get the following. Multiply with minus I. Why should we multiply with minus I? When the Hilbert transform is will be obtained, we also have to get the imaginary values. So we can multiply with minus I. Next, negative frequency for the positive frequency components by minus I and negative frequency components multiply with plus I. Here we have cos omega t. So multiply by with I. Next, apply the inverse Fourier transform. Perform the inverse Fourier transforms on the modulation frequency to spectrum to obtain sin omega t. So cos omega t is changes to sin omega t. Now we add the signal sin omega t, which means we multiplied by I sin omega t plus cos omega t. We know that the complex z is equal to cos theta plus I sin theta t is equal to e power I t. So from that identity, we got the z of t is equal to e power I omega t. Next, summary and takeaway. Why the Hilbert transforms used mainly? Powerful tool. The Hilbert transforms creates analytic signals by phase shifting components by 90 degrees, performing insight into signal characteristics. Complementary tools to Fourier transform. It is same like Fourier transform but enabling time domain complex. It complements the Fourier transform by enabling time domain signal versus analytic signal force of instantaneous properties. To get the analytic signal, we use the Hilbert transform mainly. Diverse applications widely applied in signal communications, signal processing, and analog communication. As I said, that ECG scanning, biomedical signals processing, vibration analysis for diagnostics and analytics, some signals like etc. Deeper insights. Understanding the Hilbert transforms deepens insight into signal phase. Signal phase changes by 90 degrees, amplitude, frequency, instantaneous frequency, crucial for model engineering. Further explanation applied to here Hilbert transformation to real world signals reveals, enroll, and enhance phase behinds, and practical signal. The main process of Hilbert transform is to change the signal phase straight 90 degrees to get the analytic signal, and to for modulation of the signal also we use this Hilbert transforms. So thank you for watching and giving this opportunity. Thank you.